Okay, I apologize in advance for this one because there's going to be a lot of note-taking. This is probably the most note-taking that you'll take in this chapter. Now, with these algebraic properties, what you need to know is that you don't need to memorize the properties. In fact, you use a lot of them every day. But what you do need to be able to do is you need to be able to match the name of the property to the symbols that it represents. And what I'm going to do is I'm going to go through and I'm going to give you an example of each one so you can see how they're used in math and how you've been using them for years in math. The first property is the closure property. Closure states that a plus b and a times b are unique numbers. And all that really means is that you can count on them. Every time you add 3 plus 5, you get 8, no matter what. It's the same every time. Every time you multiply 3 and 5, you get 15, no matter what, every time. And that's due to this property we call closure. So a plus b and a times b are unique numbers. After the closure property, we have the commutative property. The commutative property tells us that order doesn't matter. If I add 4 plus 3, it turns out the same as if I add 3 plus 4. So again, this is something you've been using all your life. And the commutative property works for addition. It also works for multiplication. Notice that the commutative property does not work for subtraction, nor does it work for division. So we have to be very careful about which ones we are reversing the order in. After the commutative property is the associative property. It's similar to the commutative property in that it tells us that the groups don't matter. How we group numbers when we're adding and when we're multiplying, it doesn't matter which ones we choose to use first. And in symbols, the associative property uses parentheses. So a plus b plus c equals a plus b plus c. We don't care about which way we group. Same with multiplication. So if at any point when I'm erasing these, you find that you need a little more time, just make sure you pause the video and get down the notes that you need. After the associative property, we have the properties of equality. There are 3 of them. The reflexive property says any number equals itself. So 10 equals 10. Every time we hear 10, we know what that means. We think of 10, we have a concept that goes with that number. Think of it like a reflection, the reflexive property. Next we have symmetric, the symmetric property. Just tells us that we can read equations forwards and backwards. If a equals b, then b equals a. So to give you a number example, if 3 plus 4 equals 7, then you know that you can read it the other way. Then 7 equals 3 plus 4. So equations can be read forwards or backwards. The transitive property allows us to leapfrog, basically. So if a equals b and b equals c, then we can leapfrog over the b and say that A equals C. So again, to give you a number example, if 3 plus 4 equals 7, and 7 equals 2 plus 5, then you can jump over the 7, and you know that 3 plus 4 must equal 2 plus 5. Okay, it's a pretty cool property because what we see is that there's nothing repeated on the left and the right, and yet we know they equal each other because of the transitive property there. Again, make sure to pause the video if you need more time to write stuff down. Our next property, identity property. Of addition. Both addition and multiplication have something we call the identity element. For addition, the identity element is 0. And so the property states that we can add 0 to any number and it doesn't change what we started with. So a plus 0 equals a. And we could reverse that and say 0 plus a equals a as well. So any number, 5 plus 0 is 5. A million plus 0 is a million. It doesn't matter what the number is, when we add 0, it keeps its own identity. The identity property for multiplication uses the number 1. So the identity element is 1. So, very similarly, 1 times any number is 1, other than 0. So we have to go for a non-zero number here. So a times 1 is a. Multiplying by 1 doesn't change its identity. 5 times 1 is 5. A million times 1 is a million. 1 allows the number to keep its identity. One number that is not anywhere near an identity element, and we need to make sure that we keep in mind what's happening here, is the number 0. When we multiply by 0, it gets rid of anything we had. Okay? So don't confuse that with adding by 0. Multiplying by 0 says we have 0 of those numbers, 0 A's. In other words, we have nothing. It cancels anything we have out. So 5 times 0 is 0. A million times 0 is 0. It doesn't matter what you're multiplying. As soon as you start multiplying by a 0, the whole problem is over. Next, we have the property of opposites. Property of opposites states that every non-zero number a has an opposite, which we call negative a, and when you add them together, you get 0. So, in symbols, a plus negative a equals 0. Any number added to its opposite cancels out the number. The property of reciprocals is very similar to the property of opposites. Property of opposites uses addition. Property of reciprocals uses multiplication. And it's stated very similarly. Any non-zero number a has what we call a reciprocal, 1 over a, which when you multiply them together, the a's cancel, and you're left with 1. And notice that in both of these, the properties of opposites and the property of reciprocals, your result is the identity element for that operation. So 0 is the addition identity element, 1 is the multiplication identity element. To give you an example with reciprocals, 3 times 1 over 3. Remember, if we were to multiply these as fractions, we'd put this over 1. The 3's cancel out. You end up with the number 1. So you can find a number's reciprocal by taking the number, putting it over 1, and flipping it. Lastly, we have what is my favorite property, and that's because it's so useful and we see it all the time, and that's the distributive property. So distributive property is a form of multiplication. It takes anything that we have outside touching the parentheses, and remember touching means timesing, and it shares it with the stuff inside. We say that it distributes over addition and subtraction. Okay, so this is a neat little symbol that we show to use both addition and subtraction. We could write this out separately, once with adding, once with subtracting. This is a little bit of a shortcut. So A parentheses B plus or minus C equals AB plus or minus AC. So that A gets shared with both of those things. Now notice that it is not distributive property when we have something that looks like this. If there's no plus or minus separating the two elements inside the parentheses, then we're not distributing. And that's a mistake that we make all the time, because as soon as we see something outside parentheses, we want to share it with everything inside. We can only share it over addition or subtraction. What this is right here, this is just an example of the associative property. 3 elements being multiplied together. That's all. So to go back to the distributive property, an example. Suppose we wanted to distribute 3 with the expression 2x plus 5. I like to draw these little lines to remind me that I'm sharing the 3 with everything in here. So 3 times 2x plus 3 times 5. And then I simplify. 3 times 2x is 6x plus 3 times 5 is 15. Now notice that this is as far as I can go. I cannot go any further because these are not like terms. So the first part of your assignment is going to ask you just to match the property name with the symbols. And it may help you to make some flashcards to help quiz yourself on them. Again, you don't have to memorize these, you just have to be able to match them. After that, you're going to have some problems which cause you to use these properties. Now, some of them you may not even notice that you're using properties. For example, you could just add this problem from left to right and you'd get the answer. However, if you make use of the commutative property, which says we can change the order of things, then you might notice that adding certain ones together first is going to make the problem a little easier. So 25 plus 5, those two added together, give us 30. 7 plus 3 added together give us 10. And if we add those two together, we get 40. So there's an example where we're using the commutative property, and it makes it easier for us to do the problem in our heads. So using these properties, you can go ahead and start working on some problems and see if you can identify which properties you're using when you're using them. The more familiar you are with the properties, the easier it is to find some shortcuts when you're doing your math problems.